Iceland.
To see
I wanna go
the,
to
to see the northern lights. 'Cause you-
The beaches and the hobbit places.
Well, and
So one more time, if the function is concave up, then the tangent and secant slopes will be increased. If I draw a tangent slope here, like, it's not very good, let's try again there. Hold on. We're like, a little off, one more try. That was an awkward place. That's pretty good. We'll say, we don't have any scales, so we just have to make up a number. So we'll say that this tangent slope is -9. We go along the curve to a different spot, like this. Draw a new tangent. And like that. Somebody answer the question. Would it be better to call this new tangent -8 or -10? Which is more appropriate? -8 or -10? Louder?
8.
Yeah, -8. Questions? So look, we're following a concave up curve. So we follow the curve, we find different tangents. Those tangents are increasing in value. That's what this means. Keep going, the same thing continues to happen. So maybe that's, I don't know, -4 or something. And then maybe down here, get clear to 0. Coming up the other side. Drop +4. Come here. Maybe not quite, so maybe 7. Questions from you? That's what's meant by this statement. It's also what's meant right here. If the function is concave up, then the tangent slopes will increase as you read the function. All right. The new thing is this part here, that the secant slopes also increase. So if I create a secant slope, the one up here is a little too steep to visually see it. So we'll go to here. Make a secant slope in between. So the purple tangent is -8. This one's -4. I'll pay everyone in the room. Raise your hand if you can tell me a number that might be a decent guess as to the slope of that maroon line. I'll pay everyone who's willing to try. Just look at it visually. The purple line has a slope of -8. The orange line has a slope of -4. Will be a decent guess for the slope of the maroon line. Whoever who's willing to try, I'll pay. Don't ever take payment if you're not raising your hand. That's the reward for being willing to participate. So if your hand is raised, you get 2. Bryce, what do you think? -6. Bryce guesses -6. Bryce is the vote. He gets 3 tickets. Questions? Awesome. I'm sure this thing is working here. Cool. We keep going. We can go to this one. So secant slope here as well. Same thing, raise your hand if you can give me a guess as to what that one would be. Okay, everyone is willing. Any guesses to the slope of the blue secant line? So 2 points for Danielle. 2, 3 for Danielle. Going here, let's go green. Based on Danielle's last answer, we kind of assume that's about 2. Come up here to this one. Everyone, give me a number for the purple. Give me a number for the purple. It's getting a little hard to see, but there's a tangent slope here that's 4. There's a tangent slope here that's 7. Some sort of estimate for the green, purple slope. All who's willing, raise your hands. 2 point if your hand is raised, Jasmine.
without purple one between 4 and 7. 3, 4, no, wait, not 5.
Let me just talk to you for a second.
Okay.
So the red one has a slope of 4.
Okay.
Is the
Isn't that purple one?
Is the purple more positive or less positive than the red?
More.
More positive, so a good number would be
Like 5.5.
5.5, 6, something like
Yeah.
that. We'll say 5, I don't know.
Okay.
Because the blue is 7, does that make sense?
Yeah.
3 for Jasmine. Any questions? Okay, you won't have a test question that has you do this. What you will have is you'll encounter questions where you have to make the connection on your own. That if the function is concave up, you use Danica's chart to remind you that that means the tangent slopes increase, but you have to remember that the secant slope also increases. -6, -2, 2, 5. That's an increasing set of secant slope values. The last thing is to note that the tangent and secants also increase if you alternate. So this tangent's -9. If we go to this tangent, it's -8. The next secant is -6. The next tangent is -4. So we're going from a tangent slope to a secant slope to a tangent slope, and that's a nice increasing sequence as well. Questions? Awesome. So that's the big idea. You'll need that in about 3 homework problems tonight, as well as the test has about 3 questions on it that are similar, using that idea of the tangent and secant slopes increasing. So anything about this that's puzzling anyone? The thing they'll test you on sometimes is the idea that here we have a secant slope of 2 and a secant slope of 5. The tangent that's in between has to be between those 2 values for the pattern to work. So. Okay, cool. Another new thing for today is just notational. There are a couple of problems in the homework tonight that show this symbol. That means exactly the same thing as f prime of x. I think I've told you that before. This one I don't recall ever telling you. D squared y over dx squared. It's the same thing as f double prime. So those symbols must be memorized, so if you encounter them, you'll know what to do with them. Remember on the test, there's no notes or anything on the test. The AP test, there's no notes allowed, so I have to get you memorizing things. Questions? Awesome. Another bit of just kind of notation. In some of the problems tonight, they refer to extrema. Extrema just means relative max, local max, relative min, or local min. So the word extrema is just generic for any of these.
We ran into that already.
That was last night as well. Apologies for not telling you sooner. So,
I was able to.
so it made sense enough to figure it out. Thanks, Garrett. Anybody else? Cool. So we have like 45 minutes. What I want to do now is I want to just discuss anything in the homework that you felt like, we're getting very close to the test. You saw the text that I sent out. Tonight's homework's only like, I think, 9, 8 problems long. And I'm trying to give you more and more time to get going on the practice test. So anything you want to talk about from the homework, just raise your hand and we will talk about it. So please. 22. Danielle, tell me everything you can think of first. Like, did you get partway, or did you just kind of stare at it, not really know where to go? Did you know where to start? Okay, everyone, look at me. Look up. Okay, on all these problems, really the most important thing you can do to begin with is always ask yourself, what am I looking at? What am I looking at first? And then second, what are they asking about? in most of the problems, you are, for example, perhaps looking at f prime, but they're asking you to answer questions about f. Sometimes you're looking at f double prime, and they're asking you about questions about f. That's what you need to figure out first. So someone raise your hand and tell me, in this particular problem, what are we looking at, and what are they asking questions about? Go, Randy.
We're looking at f prime and they're asking about f.
Perfect. So we're looking at f prime, and they're asking about f. I'm going to erase that. Try again here. So we're looking at f prime. The question is all about the function f. It says, what is the x-coordinate of the inflection point on the graph of f? 2 for Randy. Next thing, you need to remember the definition of inflection point. So let's see. Any function has inflection point when that function changes concavity. That's the generic definition that applies to any function. You need to kind of expand that though. So we say, so f of x has inflection point when f changes concavity. Or f has inflection point when f prime changes. Somebody finish that statement. That's how you solve this problem. Remember what an inflection point is, and you remember how to relate the values of f to the values of f prime. Jackie? Nicely done. So when f prime changes increase to decrease, let's go back a little bit. Or decrease to increase. She gets that from Danica's chart. When the function is changing concavity, like so, f prime is changing increase to decrease or vice versa. Read for Jackie, question. So be clear on the idea. Anyone? Please remember, you're never going to be tested on this problem again, but you will be tested on the idea. So somebody apply that idea to this problem and tell us how to answer the question. Smooth. So don't say it. Tell me what this it is of which you speak. So just clarify. Are we looking for an inflection point smooth on f prime, on f, on both?
On f based on f.
Well said. We're looking for an inflection point on f based on f prime's graph. So according to this, hold on. So according to this one, f has an inflection point when f prime changes increase to decrease or vice versa. So as you look at this picture, this is f prime. What kind of a change on f prime are you looking for, Smooth? Or vice versa. 3 points for Smooth. Somebody continue his thought. What are we looking for on this graph of f prime? Sage.
And then it's slope is 0.
Possibly, although I would never really look at that first, to be honest. That can lead to a mistake. 2 points though. Go.
When the graph changes from increasing to decreasing.
So Jasmine, when does this graph of f prime change from increasing to decreasing approximately?
Point 4.
kind of in here.
Yeah.
So right here, Jasmine correctly identifies 3 for Jasmine. Let's see. At x equal about 473. F prime changes from increasing to decreasing. So F changes from concave up to concave down. So F has inflection point at x equal 0.47. Questions? So just a quick follow-up. You're gonna vote. This means F, this means F prime. This means both. Don't show anyone else your vote, just show your vote right here so I can see. So tell me, did we just identify an inflection point on F prime, or on both? Or did we just identify the inflection point on F prime, or on both? Everybody gets 1 for trying. If you're doing this, you get 2 more. Okay, we used F prime, but we did not find an inflection point on F prime. If we're an inflection point on F prime, the cavity of F prime would be changing. F prime is always concave down. The cavity of F prime is not changing. We simply used F prime to find where F has an inflection point. There you go. Anybody else? Please.
5.
Number 5. Any other follow-up questions here? Quick feedback from the class. And this is second period as well. I can't wait to get your feedback. I'm always looking for the best way to use class time to make it as optimal as possible. It takes me a minute, well, it takes a little bit of time to write this down, right, so you can see the written explanation. I'm more than willing to do this if it helps you. But if I'm just wasting your time, I don't want to. So here's the option I want you to vote on. If you really like that I write this on the board as I explain it, like in words, please show me a second. You're going to show me 5. If you feel like this is a waste of time, it would be better just to say it, to save some time on the writing. You're going to say, no, just say it, don't write it all. You're somewhere in between, voting between. So 5 means, no, I love that you write it down, it really helps me. 1 is, I would prefer that you saved a little time and didn't write it down. Show me your vote. If I were to average it, probably come out about 4-ish, so pretty heavy on the writing help, so, okay. Number 5, so good.
Yeah.
Same question, somebody describe, what are they giving us, what are they asking about? Daniel?
Do you give us a prime
Perfect. So we have F prime, so we're given F prime. And they're asking about F. Okay. They want to know where F has a relative maximum. So that means we need a definition. So F has relative max when F changes. Somebody complete the sentence. F has relative max when F changes. Russ? 2 tickets, but no, it's okay. So when does F have a relative max? What's the definition? Spencer? Increasing to decreasing. 3 for Spencer. Questions? Somebody answer this one. Actually, let's do everybody. Raise your hand if you know what goes here. Read the screen statement. 5 tickets for this one. 5 tickets if you can tell me what goes here. Everyone can get them. Everyone can get all 5. So raise your hand if you know what goes here. Try to make sure you understand what the definition of a what the definition of a relative max is. So we wrote f has a relative max when f changes from increase to decrease. F prime has a relative max when f prime changes how? 5 tickets if you get it right. None if you don't try. So let's try Ashley.
Positive, negative?
So Ashley votes positive, negative. How do you vote with Ashley? Show me that. Lots of support. All of you get 1 point for a good try. Anybody have a different answer here before she said it? So Mr. Barnes, Jake, he says increasing to decreasing. How many were going to vote with Jake? 5 tickets, hold on. Yeah, the definition is any function you want. Any function has a relative max when that specific function changes increase to decrease. So f is a function, that's when f has a relative max. F prime is a different function, the definition doesn't change. Now what you get mixed up with, that's common, is this. F has a relative max when f changes increase to decrease, or when f prime changes, raise your hand if you know what goes here, I'll give you 5 more. What belongs here in blue? So f has a relative max. We're talking about the relative max on f, not f prime. It has a relative max when f changes increase to decrease, or when f prime changes. What goes here? 5 tickets. Who's ready to give it a shot? Kennedy. So Kennedy says positive to negative. How many agree with Kennedy? 5 tickets. This one could be related as well. You can put a big or here. So f prime has a relative max when f prime changes increase to decrease, or when somebody puts the whole statement there. Smooth. Questions? Are we clear on the idea? You want to talk about it all? Awesome. So we need to apply this one here to this. Because they're giving us f. So they're giving us f prime. They want us to use f prime to figure out when f has a relative maximum. So I need a volunteer. Kinsey. So here's f prime. Now, from here to here, f prime has 3 characteristics. What are the 3? When I say 3 characteristics, Kenzie, what I'm focusing on are the values in the index chart. So as I look at f prime, the characteristics I'm always concerned about are increasing, decreasing, concave up, concave down, positive, negative. So of those characteristics, name one that f prime has in this region. F prime is concave down. Kinsey, name another characteristic that f prime has. It's decreasing. What's the third characteristic that the y coordinates of f prime have?
Positive.
Nice, they're all positive. So Kinsey says these y coordinates of f prime are all positive. 3 tickets for Kinsey. Somebody else? Here we go. Mariana. Now, at this point, Mariana, is f prime, does f prime continue to be concave down through this region, or does it change? Just right here. Actually, it doesn't quite change till about here, so that's okay. So still concave down kind of in this region. Does f prime continue to decrease in this region, or does f prime change? F prime is still decreasing. Do the y coordinates of f prime continue to be positive, or does that change? Perfect. 3 for Mariana. So we could write this, oops. So we could write let's see, we could say at x equals about 0.9, f prime changes positive to negative. So f changes, how would f change right there, Marianne? So if at x equal 0.9, f prime is changing positive to negative, how would f be changing?
It would be,
Say it louder. Not quite. So when f prime is positive, what do we know about f, Marianne? F is increasing. When f prime is negative, when f prime is negative, f is decreasing. So f prime changes increasing to decreasing. 3 tickets for Mariana. Good grief. Follow-up questions, anyone? So f has what belongs here? Is it relative max or relative min? Go, Rich. Relative max. So f has relative max at x equal 0.9. That's what they're looking for. So we're done. Question. As you sit in class, what you need to do is you need to make sure that as you watch, this one, thank you, I just put it away. As you sit in class, what you have to watch for is everything we say make a logical connection in your brain? If there's ever a step that you go, whoa, where did that come from? That's all you got to say. Just speak up and say, I don't see where that came from. You know, any questions about this? You know, a different homework question you want to talk about. See? Right. Nine has a statement we probably should talk about. It says the twice differentiable function f. So let's make a couple of notes about that. If f of x is differentiable, then f prime exists. So if f of x is differentiable, you can find f prime. If f of x is twice differentiable, then f double prime exists. This idea of being twice differentiable, that shows up in a lot of AP questions. Make sure you memorize what that means. So if f is differentiable, f prime exists. If f of x is twice differentiable, then f double prime exists. Cool. So as we go back to this problem that Sage asked about, 9, you start off by saying a twice differentiable function, f is shown. So someone tell me, is this a graph of, it's not labeled, it's the graph f, is the graph f prime, is the graph f double prime. So Russ, graph is of f, 2 points. You're supposed to answer questions about f of 1, f prime of 1, and f double prime of 1. Someone just started talking about one of those quantities. Anyone may speak. Kenzie? Oh, you just hand gestures. Go.
But I found that like this tangent slope of 1 is like about like 1/2.
So Kenzie went here, drew a tangent slope, and you kind of assumed that the scales were the same. Is that fair, Kinsey?
Yeah.
So she counts it off and says, it looks like if I go over, this is 2. If I went over maybe this far and went up, it's a little hard to tell exactly what the slope is, but the key thing is the slope of tangent line, so the slope of the tangent is definitely positive. You're okay. 2 points for Kinsey. Based on what she said, what else can we write down? How does that help? Aaron?
It's also increasing.
It is true that this, well, you gotta be careful there. Okay, 3 for Gary, but everyone watch. Okay, this tangent line is increasing. This is close. The tangent line is definitely increasing. However, the slope of this curve is not increasing. Because when I say the slope of the curve, I'm not talking about one tangent line. I'm talking about a series of tangent lines. I'm talking about looking at this tangent compared to this tangent compared to this tangent. This tangent is positive, less positive, even less positive. So reading the graph, you have to say the tangent slopes are decreasing, even though this single tangent line is an increasing line. So you need me to say that again. So don't confuse the fact that this function has decreasing tangent slopes with the fact that that single tangent line is an increasing line. That's different. Okay, we know the slope of this curve at this point is positive. We need to write some more things down for help. Oh.
Well, since the slope of that thing is decreasing, would that mean that f double prime is negative?
That's perfect. Look what Jackson noticed. The tangent slope, as you read across the graph, the tangent slopes of f are decreasing. Therefore, f double prime must be negative. What's a faster way of identifying the f double prime as negative? Perfect. Super Spencer as well. F of x is concave down, so we know that f double prime must be negative. In fact, we can write this. F of x is always concave down, so f double prime is always negative. Questions? Perfect. What else can we figure out? Right hand. Rachel.
Well, I like f of when x equals 0.
Perfect. What you're looking at is good. You just kind of set it backwards. So at this point, Rachel, what graph are we looking at? F prime, F double prime. F. What's the xy coordinate of that point?
1, 0.
Perfect. So 1, 0, which means that the f function, when the x coordinate is 1, the value of that function, or y coordinate is 0. Perfect. 3 tickets. We have all the information we need to answer the question. Somebody just needs to put it together. Go, Daniel.
So f double prime is negative, f is 0, and then f prime is negative.
So double prime of 1 is negative.
Yeah.
Say the next one, Danielle.
F of x is 0.
So f of 1.
No, f is 0. And then f prime of 1 is positive.
Nicely done. 3 tickets. So now we know the order. F double prime is the least, then F1, so this one here. Questions, anyone? Please. Two ways you could do that, Miley. I like, one is to simply look at this point. Remember that this, whatever the slope of this line is, that will be the f prime of one value. It's a positive value. You can also say the function f is increasing. So every f prime value is positive, all of them. Question? You take it. You follow up here. Different homework question that we're looking to make sense of so that you can for sure get this similar concept right on the text. Rachel.
I just have a question on number 24.
Do you have a specific question or just kind of?
Yeah, I get
You're
it.
good.
So since it's giving us f prime graph and we're looking for the points and reflections on the f graph, where are you supposed to look to be able on? Where are you supposed to look on f prime graph to find? Does that make sense? Like,
So start with this, Rachel. You're supposed to find inflection points on which graph?
the f.
Perfect. So F has inflection point when F changes. Somebody, what goes there? Please. Concavity. 3 for Logan. F has inflection points when F changes concavity. Or when F prime changes, so now you can introduce Danica's chart and say you got F prime, so somebody finish this statement using Danica's chart. Go, get it.
Increasing or decreasing or decreasing.
3 for Garrett. Do you have any questions about the blue? So this is a graph of F prime. So somebody, what am I looking for on F prime to find when F has an inflection point? So, Caleb. Caleb had a PG movie and he wanted a PG-13 one. So he threw in just one extra expletive to make sure he could get to PG-13, but we don't need to do that. So. And one more time, Caleb.
When f prime changes from increasing to decreasing.
Perfect. So here's, we're looking at F prime, right? So right now, is F prime increasing or decreasing? Decreasing. Still? 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 No. How about here? Okay, good. So I could write, except we're only supposed to look on this interval. So I'm going to skip that one. I'm going to say at, let's see, this is about 1.7. Somebody, what goes here? At x equal negative 1.7, f prime change 3 for Caleb. What called? Say it louder. So it changes from increasing to decreasing. So f changes. Remember, we are looking at f prime. We can't see f, so we don't see the change on f. But because we know how they correspond, we're okay. So recall, at x equal negative 1.7, f prime changes increase to decrease. So how does f change in that exact same x coordinate? Nicely done. 3 points. Somebody, what goes here in the blank? all we know. What goes here in the blank? Show me your hands, show me your hands. What goes here in the blank? What goes here? Show me your hand. Keep your hands up. Get ready for a big bonus. If you're willing to try, I always pay. Participation helps. So if your hand is raised, you get 5. And then let's pick on somebody new. So hard to choose. Whose hands are up still? Show me your hands. Let's go Ryan. Ryan says put an F right here. How many would have agreed with Ryan? 5 more, nice. Questions, anyone? Cool. So that's how you can look at F prime and find out whether F has an inflection point or not. So Rachel, you would just keep looking at that. Does that make sense?
Yeah.
Follow-up questions, Rachel? You're good. Anyone else have a follow-up question on this one? Let's have a different question I'm hoping to discuss in class. Go, please. 14. Just because, okay, since none of you have ever taken a test that I've given you, one extra hint on the test. If you bypass homework problems with the idea of like, well, it's only one, you'll find yourself in trouble on the test. I really guarantee it. The test is tough enough that every homework problem illustrates some sort of concept that's probably going to show up again. And if you're skipping homework problems just with the idea that, oh, it won't really matter, I understand it good enough. Good enough in calculus isn't very good. Like people find out very quickly, you've got to be very precise in your understanding. So we're going to do all 3 of these to make sure we know what they mean. So the first question, so they're giving us a graph of F. The question says the domain of the derivative of F is the open interval a to b. A domain means, for answering this question, I'd say, I think of the function as being a list of xy pairs. And we start pretty close to A, not exactly A, but close to A. It's in the domain of the derivative, so this should be F prime. So somebody describe what F prime is in terms of F. Like what are we putting here in this list of xy pairs? You don't have to tell me any numbers, I just want to know the meaning of what goes in this column. Garrett?
That it's like the slope of the tangents or whatever.
Nice, perfect. So look here close to A, Garen. Again, we don't expect any numbers. If I looked at the tangent right there, what in general can you tell me about that tangent?
It's positive.
It has a positive slope. So at A, there's some positive number. I don't know what the number is. Perfect. Garen, as I go along this line, what can you tell me about different points along this line which would be different x-coordinates for F prime?
It's all the same.
So we're getting the same value. So if we said it was a slope of 3, they'd all be 3. Is that correct? We have a question about 3 tickets for Garen. When we get to C, what belongs here? So Randy's in for 2. Who else is in? Let's go Russell, Jake, Caleb. Draw worth 2 points. Ryan, Sage. What is this, Sage? And why? So you and Caleb are conspiring to have a inappropriate film. So undefined because F, not if, but because F has a coordinate. Does that make sense? Cool. 3 for Sage. So right here, it says the domain of the derivative is open interval means every x from A all the way to B, not including the ends. So this is a false statement because the domain would be every one of these x coordinates, but C doesn't count because the y coordinate is not defined. Domain means every x that has a y. And since the f prime function does not have a y value at x equals c, the domain cannot be this open interval. Follow-up questions? I lost some people. Are we okay? It says is f continuous on the interval a to b. Well, from here to here, all right, are there any holes, jumps, or asymptotes? No. So this is a true statement. Questions? Last one. Sorry. The derivative of f is positive on the open interval. I would vote that's a false statement. Somebody tell me why it's false. Why is that? There we go. Call. It's true?
Yeah.
Interval A to C.
Oh, A to
Because
C,
A to
tricky
C
beggars.
is increasing, so
Is anybody fooled like me? Raise your hand if you're fooled like me. Keep your hands up. No, thank you. Who was fooled like me? Because I feel bad that I got fooled. You get 5 tickets. So how many saw that I made a mistake? Show me your hands. Show me your hands. How many saw the mistake as I was making it? Show me your hands. Yeah, I'll give you 10. Good work. Wish I could make mistakes on purpose. It'd be more fun. But... Sierra's like, no problem. Come by my house, Mr. Smith. I'll teach you how. Don't just kidding. Just teasing.
It's all right.
It was kind of a dumb thing to say. Wish you could learn how to make mistakes. What I meant was, as you're teaching, it actually would be valuable to like make a deliberate error and see if you guys could catch it. I can't keep track of that many things at once. So if I make a mistake, it's just a mistake. Sorry, Sarah, I didn't mean to.
No, I thought it was like.
So true since, let's see, F is increasing for A to C. Please say.
So on the F prime graph, is the point at C, is that a hole?
Yes, thank you. Yeah, it would look like this. 14. If I'm making a graph of F prime, C is the interesting place, right?
Yes.
And the slope was positive initially, it was all the same. So every y coordinate will be the exact same value until we get to C. At C, we have no idea what the value of the slope is. We have an open circle, we don't know. And then right after C, the slope has some negative value. So that's what the graph of F prime looks like. Does that answer your question? It's very good. Big for six. Darren?
So like, why would that be considered like a hole?
The names can get way too confusing, honestly. So what's really important is that you simply understand what's happening. The name is secondary. Like, I don't really want that to get in the way. It's the least important part. The important thing is that you know that this y coordinate here and right here What is that y coordinate on f prime representing on f?
Just.
The slope. So we say, hey, every y coordinate's the same because every tangent slope is the same until we get to x equals c. Then we don't know what to put down because we don't know the slope. So we just leave it blank. And then right after they pick up again, that's all. Pretty sure this would be considered a jump. The thing people mix up is they think that this symbol always indicates a hole. It doesn't.
Yeah.
It's just a missing piece of information. So, yeah, I think if they were asking on a test here and they gave me choices to choose, I would definitely call it a jump. But it's still missing at that point. It's kind of weird.
The only reason I'm asking is because it says it's continuous. Like one of our true statements is that it's continuous.
Oh, F is continuous.
Oh, F is continuous. Okay.
Do you see the difference? No worries. Does that answer your question? Anyone else? Anything for the homework? Please. 19 for a second. Somebody, hey, once again, what are they giving you? What are they asking about? Here.
So the graph we're looking at is F double prime.
Giving us F double prime. And we're supposed to find
F, like something on
perfect. Two more. So we're looking for an inflection point in F. We need the definition of an inflection point on F. So we write down F has inflection point when F changes. What word goes here? Go.
Cavity.
Cavity. Or what statement belongs here for this problem? Go. Ashley.
When F double prime changes from positive to negative.
Or vice versa. Three for Ashley. Another question. So somebody tell me what I do after that. Need a volunteer, I'll help you do it. Rachel. So Rachel, we're looking for when F double prime has what kind of a change? Read this.
Increasing positive. Did you say F prime?
F double prime, so that's my
Oh,
bad.
no, you're good. From positive to negative.
Or vice versa.
Yeah.
So here we start right here, Rachel. Right here is F double prime positive or negative.
Positive.
What point does F prime stop being positive?
Let's see. 0 or 8? That-
What, like right
would that
here
be
or right
8?
here?
8.
A, very good. So F prime is positive.
Yeah.
Now F prime is
Negative.
negative. So you can write down at. So at x equal a, F double prime changes positive to negative. So F changes, somebody, what goes here? We're almost done. Somebody, go, Jake. What kind of concavity point? Sometimes. So up to down or down to up? So I don't know if it's max, but just look up. No one leave, no one leave. Listen to me. 3 for Jake, but he's making a common error. Listen close. Hey. Never associate concave up or down with a relative min and max. That's a connection that exists sometimes, but not always. If you make that association permanent in your brain, you'll make a mistake in the future. So we're looking at F double prime, trying to find where F is concave up and down. It's just down at this charge. When F double prime, F is concave up, F double prime is positive. When F is concave down, F double prime is negative. So right here, F double prime switched from positive to negative Y values. So what belongs right here? At x equal a, F double prime switches from positive to negative, so F changes. How does that change? Go. Perfect. Concave up to concave down. Good job, you guys.